Parker, what do you got? Use the lines to decide whether each statement is true or false. Be prepared to explain why. A solution to 8 equals negative x plus 10 is 2. So look at what line is negative x plus 10. That would be this line, it appears. If I plug in 2, do I get 8? Yeah, true. Next one, a solution to 2 equals 2x plus 4 is 8. So that's the other line. So if I plug in 2 to that line, do I get 8 again? Yeah, it's on that line as well, right? I plug in 2 to this equation, definitely get 8 is on that line. So that is true as well for number 2 on the next page. Question number 3, a solution to negative x plus 10 equals 2x plus 4 is 8. Do you agree with that one? Oh, go back to number 2 again. They got that one worded backwards. 2 equals 2x plus 4 is 8. That means if I plug in x equals 8, x equals 8 will not be that same point. So that one actually has to be false. I thought that said 2 again. If that was a 2, it would be true. So this one is actually false. It would have to be 2 and 8 again. Question number 3 is the same thing. If I plug in 8, x equals 8, is that a solution? Again, that is false because we know that x is 2. So anytime you see that x is 2 there, that will be true. Question number 5, there are no values of x and y that make those lines true. That means those two lines will never cross. Is that true or false? Yeah, they definitely cross. So that one is false. All right, question number 2. I'm going to give you about a minute to try this one. Gives you 3 equations or 3 graphs and 3 sets of equations. Okay, A, B, and C. Why don't you see if you can just match those? Which equation is which? Some hints, look at the y-intercepts and look at the slopes. All right, got a match, Wyatt?
I think so.
All right, which one are you confident on?
Pretty confident that B goes with C.
B goes with C. Looks like y-intercepts of 12 and 27. I agree that. There's only one here that has both of them y-intercepts below the origin. That would have to be this one, where it crosses the y-axes are both below the origin. So that is C. That means A goes with A. You can probably tell that by looking at the y-intercepts or the slopes. It's the only one that has one line that's going up and one that's going down as well. Either one is just fine. All right, question number 2. Find the solutions of each system and check your solution is reasonable. See if they work. So let's guess and see where they meet. That is what it means by solution. Say for A, what does it look like they meet at? Say that again? 515. Now, if you'd plug in 5 and 15, you would see that doesn't quite work. It is a little less than 5. And it's actually a little less than 14. You can't tell that by looking at the graph, so you'd have to plug it in for X and Y to try it. It's actually 3, 14 is what would make it true, and you plug them back both in there, and they would be just fine. Both of them would be true. So that one is 3, 14. Again, you can't tell just by looking at it. Question B, you want to make a guess on that one. The x-axis should be pretty obvious, I think. Y maybe not so much. Graph B is -10, 7. Again, you plug those back in, it will be true. And graph C, this one would be the toughest of the 3 because it's not a whole number. -4.5 and -19. All right, so the next one, I'm going to give you a sheet of paper, and you can work with a partner on this. It's got 6 graphs on it. Okay, it's got 6 graphs on it. And I want you to graph it the best you can. And then we're going to discuss, and you should already be able to answer this, but every one that has no solution should be obvious. How can we tell by looking at the graph? How can we tell by looking at the graph that they're infinite solutions? How can I tell that they have one solution? So I'd just like you to practice graphing those. So go ahead and get in groups. It's actually 5, not 6, my fault. And if you have parentheses, you're going to want to distribute to start. Guess you only really need one per group. Give you a few minutes. Again, if you have parentheses, distribute first. And graph away.
I love that. Yeah. Don't talk to me again. Favorite now.
that distribute though. Get rid of the parentheses. Yeah, past parentheses, you're gonna have to do distribute first. C is probably the easiest. You don't have to do anything with that one. All right, if you want to check the first one, you distribute up on the two equations, that's what you should get. See, they have one solution and you can see where they're at. If you're careful, you graph it. All right, must be having some technical difficulties because it is still recording, but it's not showing on the screen there. But the other one, the top equation, you should have 5x minus 15. Graph it, and the bottom one, of course, is 2x minus 6. They should meet at 3, 0. They should meet at 3, 0 there when you graph it. Question C. Put a dot at 3, y-intercept of 3, slope is 2, up 2 over 1, up 2 over 1. Connect the dots. Second one, the y-intercept is 5, same slope, up 2 over 1, up 2 over 1. Should have parallel lines there, they should never cross for C. Question D. Question D, negative 6x, that means the y-intercept is 0. Put a dot right at the origin on the back page. A dot right at the origin, right at 0. Slope is negative 6, down 6, right 1, down 6, right 1. Connect the dots. It does say there's no solution, so what should that tell you about your lines? They're parallel. They don't meet. So if I distribute on the bottom one, letter D there, I'm going to get negative 5x plus 10 minus another x. So that'll be negative 6x plus 10 if you combine like terms. So up 10, same slope. Down 6, right 1. Down 6, right 1, parallel to the one you just made. They should never cross. Okay, letter E, it says infinite. What's that tell you about your lines? They
don't have the same slope.
More detail than that. They're the exact same line. So I'm going to graph the bottom one, 2x plus 3. So up 3, put a dot. Slope is up 2 over 1. Up 2 over 1. And the other one is going to be the exact same line if you were to simplify it as well. You only have to graph one line because it is the same. If anybody would like to see those, again, since there's something going on with the internet or Bluetooth, it appears, the graph will be up here for you. Take a look at the homework at 104 here before you go back. Okay, question number 1 is going to be really good for you. Write the equation of the two lines. Blue one and the black one. Should be able to write that pretty easily. Slope and y-intercept. B, how can you find the solution by looking at the graph? That should be simple. C, how could you find the solution by using the equations? Again, we've done a lot of that as well. Question number 2 is multiple choice. It says choose two equations that might make up the solution. It gives you the x and y coordinate there. If you plug it in, it's got to be true. So plug in 5 for x, negative 19 for y. Which ones are true there for number 2? Question number 3 and 4. Okay, gives you two equations. It says solve them. Okay, since it says they are y equals, you can put them equal to each other. So that first one, I'm going to write 4x minus 3 equals negative 2x plus 9. And then you're going to solve it for x. Okay, add 2x to both sides. Add 3. And then you should be able to figure out what x is. Now that's only half of your answer. That's only your x. You'd have to plug it into either equation to get y once you get x. Now let me just double check. You get nice whole numbers for 3. 4, you get a whole number and 1 decimal. The y ends up being a decimal if you want to mark that down for number 4. The y ends up being a nice decimal for number 4. Question number 5, solve by using the distributive property. Solve without using the distributive property. I don't care how you solve number 5, just show your work for it. So you can kind of alter the directions there. Solve any way you want is what I want you to do for number 5. So 1 through 5 for tomorrow, please.